Hey guys, so here we are in section 2.4 and 2.5. This is chemical reactions and enzymes. I put the two sections together because there's not a whole heck of a lot that we need to know for these sections, and they go hand in hand. Our key concept for this section is life depends on chemical reactions and that enzymes are catalysts for chemical reactions in living things. Our vocabulary, we have chemical reaction, reactant, product, equilibrium, activation energy, exothermic, endothermic, catalyst, enzyme, substrate. Our main ideas: bonds break and form during chemical reactions. Chemical reactions release or absorb energy. A catalyst lowers activation energy. And enzymes allow chemical reactions to occur under tightly controlled conditions. Our essential questions: what happens to chemical bonds during chemical reactions? How do energy changes affect whether a chemical reaction will occur? What role do enzymes play in living things and what affects their function? All right, so if we start to talk about chemical reactions, well, chemical reaction is a process that changes one set of chemicals into another set. Now, it does this by either breaking or forming chemical bonds. So either we put two things together and they create something new, or we put something and we react something with it, or have something happen and it creates other things. It either breaks apart and turns into a different substance. So the compounds that enter into a chemical reaction are called the reactants. We're putting them together to react. We want something to happen. So that's the front part. The compounds produced from the reaction are called the products. So whatever you put together initially, again, that's the reactants. The end product, products. Okay? So if you look down below, you can see I have A plus B, and then I have this arrow sign. You can kind of think of like the arrow as the equal sign. So if I put A and B together, they're going to react to form this new thing, which is AB. Okay? So I've got my reactant side and my product side. And chemical reactions release or absorb energy. So all chemical reactions involve changes in energy. And some things actually take energy in to make them start, and some things actually release energy as they happen. So energy is released or absorbed whenever chemical bonds are broken or formed. Now, the energy that's needed to get a reaction started is called the activation energy. It's how much energy you need to either put in or take away in order for something to happen. And we can show this by using an energy diagram. Okay, so we've got this chart that's showing a reaction happening. And the amount of energy that it takes to actually have that reaction start happening is called that activation energy. A reaction that is at equilibrium is when products and reactants are forming at the same time. So your reactant side is the same as the product side. And equilibrium is one of our vocabulary words. And again, in equilibrium is when reactants and products are forming at the same rate. So we have one thing turning into something new, and that new thing breaking down into those old two things. And now we have exothermic reactions and endothermic reactions. In an exothermic reaction, they actually release more energy than they absorb. Exo, you can think exit. EXO, exit, is energy is being released. It's exiting from the reaction. Endothermic, they actually absorb the energy. So endothermic, you can think endo, like entering. So they're absorbing the energy. Okay, and then we have our reactions and our energy graphs down there. Now we have this thing called a catalyst, and a catalyst actually lowers that activation energy. So if it took a lot of energy to get that reaction to start, if we add a new chemical called a catalyst, it actually lowers that amount of energy that it takes to start a reaction. So some chemical reactions that make life possible are too slow or really high activation energies to make them actually practical for our living cells. And so these reactions are made possible with the use of a catalyst. And again, a catalyst just speeds up the chemical reaction. And it does that by lowering the activation energy. So it doesn't take nearly as much energy for that reaction to get started than it did without the catalyst. So we decrease the activation energy and we increase the reaction rate. It speeds it up. by using that catalyst. So we have this chart here, and you will see this chart on the EOC. You might see it on the midterm as well, where they ask you what is happening. And if you look at that little dotted line, that dotted line is showing the change in the amount of activation energy. Now, our initial reaction, the normal reaction, is that orange line, not the dotted one. So where it says normal reaction, and it's showing how much activation energy is needed. But if we actually add the catalyst, you can see how that activation energy has been reduced. So by adding the catalyst, we have reduced the activation energy needed for that reaction to happen, thus speeding up the reaction. So enzymes allow chemical reactions to occur under tightly controlled conditions. And all enzymes are biological catalysts. They're catalysts that are inside our cells. So they speed up the chemical reactions that happen inside our cells. And enzymes are actually proteins. And remember, we talked about proteins. Proteins were made out of amino acids. Super, super, super important. They do so many things. And I told you they control the reactions in cells. They do that via enzymes. So enzymes are proteins that act as biological catalysts. They speed up the chemical reactions that take place in our cells. Now, how do they do their job? Well, enzymes provide a site where they actually can bring the reactants together to react, okay? So it's kind of like a puzzle. We put these things together, all right? So the site reduces the amount of energy needed for that reaction. Now, when those reactants get brought in, they sit right there on the enzyme and they react. So reactions of enzyme catalyzed reactions are called substrates. Those are just the reactants, the products, well, the things we're bringing together to react. They're going to create a product. But the enzyme allows them to have a place to come together very close so they can react. And the substrate binds to a place on the enzyme called the active site. So the most important thing for you to remember on this is that enzymes are biological catalysts. They speed up the chemical reaction. And they do this by providing a place for those reactants to go through the reaction process, the chemical reaction process. So the active site and the substrates have a complementary shape, all right? They don't all fit together. Certain enzymes do certain jobs. We learned about that in macromolecules, that the structure determines the function, okay? So how it's built determines the function, the job it does. So we have our substrates, they lock onto that enzyme, and it allows them to go react to create a new product. Okay, so there are a few things that actually can affect enzymes, all right? Remember, we learned that the structure of something determines the function, the job it does. And because enzymes are proteins, if they're not the right shape, they're not built the right way, they cannot do their job. So an enzyme's function depends on its structure, and they only function in a small range of conditions. Like it has to be very, very, very specific. And some things that can alter or change the way an enzyme works is the temperature. If the temperature is not right, the enzyme's not going to work. If the pH is wrong, if it's out of whack, it's not where it needs to be, it's not going to function properly. We have other things called regulatory molecules. They control what's going on in our cells, and those can also affect how well enzymes work. But the big takeaway is that the structure determines the function, and if an enzyme ends up where it doesn't belong, like it was supposed to be in a pH of 8, but now it's in a pH of 6, it's not going to have the same structure and it's not going to work properly. All right. So anyway, that's the end of 2.4 and 2.5. Please go back, see if you can't answer those essential questions. If you need anything at all, you know how to contact me and let me know what you need. All right, thank you guys.